So we have gone over how to create a class and how to create a struct, and they both seem pretty similar, right? Now let's go over one of the biggest differences, and that is their type. A structure is a value type, and a class is a reference type. Now, if that means nothing to you, don't worry, we are going to try and illustrate what those definitions mean. I will first give you the technical definition, then we're going to try to relate that to a real-world example, then see how this works in code. All right, so structures are value types. This means that when we pass instances of a structure within our app, we are actually passing a copy of the structure and not the original structure. So changes can be made to the passed structure without any changes occurring to the original struct. But classes are reference types. This means when we pass an instance of a class, say from one view controller to another, we are passing a reference to the original instance. This means that any changes made to the past instance will also be applied to the first instance. So now an example. Say you are working on a Google Doc, and then a coworker needs access to it as well. So you share it with him and go to lunch. You come back and see a whole bunch of changes made to the document. This is an example of passing by reference, like classes do. You shared a reference to the document, and any changes made by him are reflected in your version as well. Now, by contrast, say you were just working in Word or Pages. You save the document, attach that document to an email, and send it to your coworker. You can both now work on and make changes to the document separately without affecting the other's document. This is an example of how structs are passed by value, where a copy of the struct is made and modifying a copy does not affect the original. All right, so now let's see how this works in code. All right, so we have our dev struct here, and we have our dev class. All right, so we need to simulate passing these instances, and we can do that by saying we're going to create a copy here. So I'm going to say var copy dev struct is equal to dev struct. Okay, so now we have our original and we have our past instance. So now I'm going to modify both of these, and then we're going to print out the results and see if they've changed. Okay, so I'm going to say dev struct, so this is the original, dot first name is equal to, and let's go ahead and say Johnny B. Then we're going to get the copy dev struct dot first name is equal to Fernando. Okay, and now if I print these, print dev struct dot first name and print copy dev struct dot first name, and we run this, as you might expect, we see different names. Johnny B, this is our original, and Fernando for our copy, okay? So when I initialized this second variable, we made a copy of the original dev struct. All right, now let's take a look at how this works with classes. So I'm going to first create a past reference to our original dev class. I'm going to say let past dev equal to dev, which is already an initialized instance of a class. And then we're going to change the first name for both of these. Okay, so I'm going to say dev dot first name is equal to, and again, we're going to start out with it being Johnny B. Then we are going to change it to, let's see here, what did we name it? Past dev. So now we're going to change the past instance of our class. So this is the one that was passed by reference. And this is going to say past dev dot first name is equal to Sally. Okay. And then we're going to go ahead and print both of those. So I'm going to say print dev dot first name and print past dev dot first name. All right. So now, even though here I said that dev dot first name is equal to Johnny B, so you might expect this to print Johnny B, unless of course you've been paying attention, in which case you know that both of these are actually going to print out Sally. So you might expect this one to print Sally. Okay, I'm going to comment out these two here and run this. All right, and sure enough, here we get printed out Sally twice. And that's because after we assigned Johnny B to dev, we then assigned Sally to our past reference, okay? And because these are passed by reference, when I made the change to first name for past dev, it also applied that change to dev, the original instance. And that is what we mean when we say that structs are passed by value and classes are passed by reference. All right, so we've talked about the two big differences, but the question you probably still have is, how do I know which one to use? This has been an ongoing debate over the years, and seems to be a bit of a shifting debate as well. If you Google something like when to use struct or class Swift, you will most likely find answers that reference this bit of Apple documentation. Structure instances are always passed by value, and class instances are always passed by reference. This means that they are suited to different kind of tasks. And then it goes on to say that as a general guideline, consider creating a structure when one or more of these conditions apply. When the structure's primary purpose is to encapsulate a few relatively simple data values, and the structure does not need to inherit properties or behavior from another existing type. And then it shows some good examples, or some examples of good candidates for structures, including the size of a geometric shape, perhaps encapsulating a width property and a height property, a way to refer to ranges within a series, a point in a 3D coordinate system. But the important part is down here. It says, in all other cases, define a class and create instances of that class to be managed and passed by reference. In practice, this means that most custom data constructs should be classes, not structures. However, this appears to be outdated documentation, because if you click here where it is referencing, then that takes us to this documentation with structures and classes, which then links to this article, choosing between structures and classes. And in this article, it very quickly makes it clear that the recommendation is to choose structures by default. I'm just showing you this so that you don't get confused later on if you see this in other Stack Overflow answers, or someone is trying to tell you that the Apple docs say to use classes by default, because they are referencing old information if that's the case. Because the latest recommendations from Apple is to use structures by default. Okay? So let's just browse through here real quick. It says that structures and classes are good choices for storing data and modeling behavior in your apps, but their similarities can make it difficult to choose one over the other. And then it has these recommendations. As we've seen, we are to use structures by default. We use classes when we need Objective-C interoperability, and we use classes when we need to control the identity of the data you're modeling, okay? So let's take a look at choosing structures by default. This example, or this older documentation, still has good examples of good candidates for structures, things like geometric shapes and like a point in a 3D coordinate system. Basically anything that you want to just kind of hold some data. That is a good use case for a struct. However, Swift structures can also adopt protocols to gain behavior through implementations. And we'll talk more about that later, all right? But for right now, you should know that you just choose structures by default and only use classes when it is appropriate, okay? So like we said, use classes when you need Objective-C interoperability and when we need to control identity. Let's dive a little bit deeper into this identity here. It says that classes in Swift come with a built-in notion of identity because they're reference types. This means that when two different class instances have the same value for each of their stored properties, they're still considered to be different by the identity operator, which is 3 equal signs. It also means that when you share a class instance across your app, changes you make to that instance are visible to every part of your code that holds a reference to that instance. All right, so let's take a look at this identity operator. I'm going to jump back into Xcode, and I have just a little snippet of code that I'm going to paste over here. And what we're doing is we're just creating 2 instances of the developer class with the exact same values, just like it said here, that we have 2 different class instances with the same value. And if we print this, we're going to get an error here because Playgrounds is having some issues. Let's go ahead and I'll take this and paste it up here. And let's try that again. And you can see here that is printed out false, meaning that they are not considered to be the same. Now, this can be useful, having changes propagated throughout the app when you change a property on a class, but if we look at this important note here, this can be a little bit dangerous. It says treat identity with care. Sharing class instances pervasively throughout an app makes logic errors more likely. You might not anticipate the consequences of changing a heavily shared instance, so it's more work to write such code correctly. Okay, so going back to our Google Docs example, it's pretty easy to keep track of who's making changes when there's only 2 people working on a Google Doc, right? But what if you shared that with the rest of your company and all of a sudden you have, like 50 people making edits and changes to that Google Doc? Very quickly, that could become unmanageable and no one would really know what it says. Okay, so that is the danger that is being warned about here, okay? Lastly, I'm also going to link to this blog article, and it has a pretty good TLDR down here, too long didn't read. And this is also a fairly old article before they made the change to do structs by default. But this TLDR I think is pretty good. It says that structs are for bags of data, your ints, your CGRect, your person record, all right? So that's talking about like if you just need an object to just hold data. You're not performing, network requests or anything like that. It's just to hold some data. If you find yourself talking to something else inside your struct code where something else is the file system, the network, the GPS, you have made a wrong turn somewhere. Or in other words, he's recommending that classes would be better for this. If you find yourself with structs that contain structs that contain structs that contain structs, you have probably made a wrong turn somewhere. All right, so I'll link to this article as well. And finally, we're going to finish up taking a look at a couple of examples from the core Swift and UIKit libraries, okay? So we've already taken a look at UI color, but just to take another look at it, I'm gonna command and click and jump to definition. And here we have a class, and we can see all these initializers, open class vars, functions. It's a pretty extensive class, okay? Now let's take a look at a CG point. And don't worry if you don't know what these classes and structs are yet. We'll be using these later, but just to kind of illustrate the differences between classes and structs in practice, if we click on this one, you can see here that we have a struct. And indeed, it is just holding a couple of properties, an X and a Y coordinate, and we have 2 initializer. We do have some extensions, but the basic struct is kind of just a bag to hold data, okay? And then 2 more examples, UI view controller. This is obviously a pretty big and important class. And as you can see, it's got a whole lot of functions, methods, variables. And yeah, so that is a class. That is a big one. And then we have another example of a struct, CGRect. This is a rectangle. And so we have, again, just a few stored properties and some extensions and more simple, okay? All right, so I hope that clearly covers the differences between classes and structs. Classes are passed by reference, structs are passed by value. Use structures by default, except for when it makes sense to use a class. And I will be linking these articles and blog posts in the next lecture's article, all right? So if you need to go and do a little bit more research and reading, I highly recommend that. And if you have any questions, please feel free to leave them in the Q&A, and I'll do my best to get to them, all right? This has been Johnny B, and I'll see you in the next one.